Hey everyone, in this video I'm going to focus on LIN network or local interconnect network to see what is LIN network, where you can find it on the car and how it works. So we already have a couple of other videos about the network, mostly on CAN Bus. And after publishing those videos, I received many messages and comments to make a video about the LIN network as well. So that's why today I'm making this video for you guys. First of all, we will start by having a look at the network, LIN network basic. Normally, when we are talking about the LIN network, you guys are supposed to know where to find it. So I'm gonna show you some really good examples about the LIN network on the Venn diagram and a couple of experiences as well. So you will, at the end of this video, you will know the application of the LIN network. Then after having a look at the power window and power seat application, we will continue by having a look at the parking assist system to see how LIN network is used in parking assist system. Then we will have wiper and the rain sensor, because LIN has been used on wiper and rain sensor as well. And the last one is going to be the headlight. So we are going to focus on the main subjects and main systems, and it doesn't mean that you will not find LIN network in other systems as well, but these are the major and main components using LIN network. And if you watch this video and if you know how LIN works, obviously it's going to be super easy to find the LIN network in the other systems just by having a look at the wiring diagram. All right, so as I said earlier, we have a couple of other videos for the CAN bus. I will leave the link of those videos in the description so you can watch the CAN bus structure and diagnostics video as well. But basically, when we have the network in the car, I'm just giving you really quick idea about the network. Then we will see why do we need to have a LIN network. So basically, network is designed to minimize the need for having the wiring, because you see all these control units, you may have even more than these control units on one car. So it means when you have so many control units and when they are communicating to each other, you need to have so many wires and wiring harnesses in the car. So having more wiring, I'm not really worried about the cost side. I'm just worried about the diagnostic side. When you have so many wiring, it means you may have so many problems. Connectors or the wirings, they are normally the source of the problems. So companies are using the network to minimize the wiring and the wiring harnesses. This is the first one. And on the other hand, using the network is going to give this ability to the companies to share the information between the control units at higher speeds, right? Because when you are using a normal hard wire, so control units are sending the signals as usual, just a voltage or whatever they are sharing to each other. But now, when they are using the network, information will be shared at really high speed. For example, here on high-speed CAN, all these control units are connected to high-speed CAN. So they will share the information using this network, and the speed that we are using in the high-speed CAN can reach to 1 megabit per second. So it's going to be way higher than the normal hard wiring. And on the low-speed CAN, that normally we call it body CAN, you see some other control units like the driver door module, assist door module, power seat, and a couple of other things, other control units. They are sharing the information at lower speed, but still it's not comparable to a normal hardwire, because in low speed CAN we can reach up to 125 kilobit per second, which is still really good speed. So when you see these two classes of CAN right now, you see those control units which are really critical, like engine, brake system, transmission. So these are really sensitive, really critical. We need to send the information and we need to share the information between these control units as quickly as possible. That's why we are using the high-speed CAN. But the other control units right here in the body CAN, they are less critical. All right. So it doesn't mean that their information is not important at all. Of course it is, but this information is not as critical as these information in the units in high-speed CAN. So that's why when we are using the low-speed CAN, we are still using the network, but we will have less speed compared to the high-speed CAN. So when obviously you are using less speed, the total cost of creating these control units is going to be less than the high-speed one. But is there any need for sharing other information? Yes, of course. Of course there is. So we already know about the low-speed CAN and high-speed CAN. But sometimes there are some other components, mostly some sensors. They need to communicate with these control units connected to the beacon or to the high-speed CAN, right? So it means if we have other components which are even less critical than these control units in the low-speed CAN, instead of using this kind of network, instead of using the CAN network, we're going to move to another network, which we call it LIN network. So in the CAN bus, if you watch the other video in the description, you see that the CAN bus is using a pair of twisted wires. So it means you have two wires which are twisted to each other in the CAN network, and the speed that you reach is 1 megabit per second in high-speed CAN and 125 kilobit per second in low-speed CAN. But if you have any other component which needs to send the information, which needs to share the information, less critical as low-speed CAN, but still you are trying to share the information faster than the normal hardwire, we can move on to another network which is less critical and which is going to cost way less than low speed CAN. So that one is LIN network. So LIN is the abbreviation of local interconnect network. Local interconnect network. And in the LIN network, we are using only one wire. Only one wire. Not two wires anymore like the CAN network. There is just one wire to communicate. So normally you can find the LIN network in these systems and obviously more. So I've seen the LIN network in sunroof, in the power door lock system, in headlight that we will see today, in power seats, in the wiper and rain sensor, and sometimes in parking assist systems. And obviously, as I said earlier, in some other systems as well. So let's have a look at the structure of the LIN network, then we will start talking about the different systems using the LIN network. So this is a simplified structure of the LIN network. So normally on the LIN network, we have one master node, which is normally your control unit, and there are some slave nodes. So these are normally your sensors. And as you see, there is only one wire, which is LIN network. So this wire between the master node from here to this slave and the other one. And the important point is you don't need to separate LIN line for each node. All right, so the master node is sharing only one line. All right, and as you see, these two are connected to each other. So this is gonna minimize the need for wiring even more. All right, so this master node is going to be your control unit. The slave node is going to be your sensor, which is working with the master node. If you remember the CAN bus, CAN bus is some sort of multi-master network. So all the units connected to the CAN network, they are a master node. So they can share the information and receive the information or request the information from the other control units. But on the LIN network, we only have one master and multiple slave. Okay, one master node and multiple slave nodes. So for example, if you are talking about the parking assist system, master node is going to be your control unit, and the slave node is going to be all the parking sensors. And if you consider the front parking sensors and the rear ones, it's going to be more than 10. All right. So this is really important to consider. A LIN network can share the information up to 20 kilobits per second. But obviously on the CAN bus, we have 125 kilobit per second for the low speed CAN and 1 megabit per second on the high speed CAN. So this one obviously is way slower than the other kind of networks, but it's still much better than the normal hard wire. And normally the voltage in the LIN network is going to be 12 volt, is using a 12 volt. And normally this is what we get if you check the waveform on the LIN network. All right, let's start to have a look at some systems using the LIN network, so you guys will know how to find it in the wiring diagram. So on some cars, the communication between the driver door module and assist door module is via CAN bus, low speed CAN bus. But on some other cars, this communication is going to happen via LIN network, right? Because this communication is not really critical, and they can reduce the cost by using the LIN network instead of the body CAN. So what happens? For example, you have the power window. If you are trying to open or close the other window, or for example, you are sitting on the driver's side, you are trying to open or close the power window on the passenger side. Normally, when you are requesting from here, when you are trying to open or close the window from here, you are communicating to assist door module or passenger side door module via LIN network, right? So it means if we didn't have LIN network, what was the situation? So you needed one line for the closing request when you wanted to move the window up, and for the down, right? For different requests, you needed one individual wire, right? But right now you are just using one wire, which is your network. So right now your door module, so right now your driver door module is communicating to assist door module via LIN network, and really doesn't matter how many different signals they need to share with each other. They're going to use just only one wire, which is the LIN network. Driver door module and assist door module are using the LIN network, and IMS ECU is exactly the power seat control module with the memory, okay, when you can memorize the situation of the power seat. So as you see, the power seat control module is communicating to IPM, which is your fuse box, via LIN network as well. So in normal situations, these four control units needed to share so many wires, but now they are just using a normal LIN network. All right, guys, next one is parking assist system. So as you see on this parking assist system, we have the smart parking assist system control module right here. 4 sensors on the rear sides, 4 sensors on the front side, and we have 2 side sensors. We may have 2 other side sensors in the rear side as well, based on your car. And as you see, all these sensors normally need to communicate directly to a smart parking assist system to send the information, to send the signal. But right now they are using just a LIN network, and the information is shared at higher speed compared to the normal wire. But let's see how this LIN network works on the real wiring diagram, like this one. So this is the wiring diagram for smart parking assist system, and as you see, this is the control module up here, and right here we have 2 LIN networks, LIN 1 and LIN 2. So if you focus on LIN 2 goes all the way to side sensors. So this is the side sensor. As you see, this one is side sensor, the other one is side sensor as well, right? So these two side sensors are connected to LIN 2, and LIN 1 with this color, this one is connected to all front parking assist sensors, right? But they are going to the rear parking assist sensors as well. On the second page, we have again LIN 2. We have again LIN 2 for another two side sensors on the rear side, because for this one we have another two side sensors on the rear side. And LIN 1 again is connected to 4 parking assist sensors at the rear side. So it means LIN 1 is connected to 8 sensors, and LIN 2 is connected to 4 sensors. So this is how you can find the LIN network on the wiring diagram. And as you see, I just like a normal wire on the sensor. So right here on the sensor, you have these pin numbers, 2, 4, 6, and 5. Number 5 with this wire color, yellow and orange, this one is the LIN network, and same on the other side as well. So what will happen if you have any fault on the LIN network? I'm going to show you one example from actually what I had one time on one car. I had a Kia Sorento 2017 one time, and the problem was that car had a crash from the rear side, from the rear left, and apparently customer took the car to a panel beater. They just replaced the rear bumper, and apparently they tried to remove the sensors and put them back on. But right after finishing everything, after finishing the panel beating job, customers saw a fault on instrument cluster for a smart parking system. And when he brought the car to our workshop, when I checked the car, I had this fault, C1360 smart parking assist sensor lane short. And when I removed the rear bumper, this is the bumper when I removed it. You see this bunch of wiring right here? I removed the bumper, and because I was just trying to see what's going on with the sensors, I removed the whole bumper. And this is what I found. You see these wires? This one and this one. So apparently that guy who was doing the panel beating job, or the one who replaced the rear bumper, they didn't know how to fix the problem on a smart parking assistant system. They just cut the connector from one sensor, and this is what you see. Because maybe the connector was broken after the accident or whatever, because I couldn't find the connector anyway. They just cut this wire, and one of them is the LIN network, because I wanted to see if the problem is just right here or in any other place in the wiring. I just tried to fix the wiring just quickly, just like this. I put some pins on the wires, okay, to secure them inside the sensor to see if the fault code is going to go away. So after crimping these pins on the wires and inserting them into the sensor, everything started to work as normal, and we didn't have the fault code anymore, because obviously technically they cut the wire, and this cutting the wiring caused some short circuit as well. So we had this problem on the LIN network. So the next one is the rain sensor. As you see, this is the wiper system. We have the body control module here, front wiper, low speed relay, and the high speed relay. So obviously body control module is responsible to energize the relays based on customer request. But when you have the rain sensor, it means anytime that you put the wiper switch on auto mode, what happens if you're driving and it starts raining, rain sensor is going to detect that, and it will send the information back to the BCM to operate to energize the Viper relays. But in this case, as you see, we have only LIN network. We have only LIN network. Instead of having a couple of wires for communication between rain sensor and body control module, we only have one wire, which is the LIN network between the BCM and between the rain sensor. So anytime that is raining, after rain sensor detects that, it's going to share the information to the BCM via this LIN network, and BCM is going to energize the Viper relay to operate the front Viper. And the last one for this video is adaptive front lighting system, or AFLS. So on this system as well, as you see, we have some actuators in front lighting system for leveling the headlight, or to adjusting the headlight when you're cornering. So for this one, you have one control unit, some sensors to detect the vehicle height, and the actuator. So in this system, control module is communicating with the actuators using the LIN network. So far we had the sensors, now we have the actuators. So for different mode of actuation, because the leveling actuator has different mode, and even on the cornering. So instead of using all those wires for actuating the actuators in front lighting system, we only have one LIN network, and as you see, even these two actuators are using very same LIN network. Okay, let's have a look at the wind diagram for adaptive front lighting system. And as you see, this is the control module, and we have the headlights left side and right side in here. And as you see, we have two actuators in here. So all the control functions for these actuators are controlled just using one LIN network. So it's one LIN network connected to the control module, and it's shared between the left side and right side headlights. So instead of using so many wiring, we just have one LIN network, which is quite reasonable. So this is a code that sometimes I had for the LIN error on adaptive front lighting system. Normally when there is short to battery or short to ground in the LIN network. And surprisingly, a couple of times I had this fault because of the internal short inside the headlight. So the control unit was okay, the LIN network itself was okay, but after headlight replacement, everything was back to normal. So you need to keep it in your mind that sometimes, like CAN, we may have this fault on the CAN as well, internal problem or internal short inside the control module on the CAN transceiver. We may have this fault on the LIN network as well if there is any internal short in the slave node. All right, thank you very much everyone for watching this video. Please don't forget to have a look at the other video for CAN Bus network if you haven't watched it so far. And if you like this video, please don't forget to like it and share it with your friends.